Have you ever had one of those days where you feel like you've been running around like crazy, but you've gotten absolutely nowhere? Well, that's not just a feeling, my friend. That is literally a physics concept. Today, we're going to break down the difference between distance and displacement. Two ideas that, they sound almost the same, but they actually measure two completely different things about any journey you take.
So let's just jump right in with a little puzzle. Picture this. A farmer walks a total of 140 meters around his field. That's a pretty good stroll. But when he finally stops, he's only about 14 meters away from his original starting spot. So, how is that even possible? Now, this isn't some kind of trick question, I promise. It's just physics at its finest. To crack this little puzzle, we've got to get a handle on how physicists actually measure movement. It turns out there are two very different ways to talk about a journey, and that is where the secret to our farmer's situation is hiding. Okay, so these two essential tools are called scalars and vectors. And trust me, understanding the difference between them is the key to solving our farmer's puzzle and a whole lot more in the world of physics.
The difference is actually way simpler than it sounds. A scalar quantity just tells you how much of something there is. Its size, its magnitude. Think about things like mass, or the time on the clock, or the speed your car's going. A vector, on the other hand, is a little more specific. It gives you both the how much and the which way. A great example is force. It really matters how hard you're pushing a box and which direction you're pushing it in.
Okay, so let's apply this. Distance is a classic scalar. It's the grand total of the ground you cover. If you walk to the store and then walk back home, your fitness tracker is adding up every single step. It only cares about the total number, the magnitude. It's just a running tally.
But then you've got displacement, and that's our vector. Displacement really doesn't care about the scenic route you took. Nope, it only asks two simple questions. Where did you start, and where did you end? The displacement is just the shortest, straightest line, the shortcut between those 2 points. And because it's a vector, it includes the direction from your start to your finish.
So we have our two contenders, scalar versus vector, distance versus displacement. Let's put them head to head and see how they really stack up against each other. Let's really break this down. As we've said, distance is a scalar, displacement is a vector. This means distance is what we call path-dependent. Every twist, every turn, every step gets added to the total. But displacement? It's path-independent. It couldn't care less about the journey. It only cares about the starting line and the finish line. And here's a super important point. Once you start moving, your distance is always a positive number. But displacement? Well, it can be positive, it can be negative, or it can even be zero.
Here's the absolute best way to lock this into your brain. Think of distance as the full story of your journey, every single detail. Displacement is just the headline, ended up 5 miles northeast of home. It's that simple. One is the process, the other is just the end result.
All right, we are officially armed with the knowledge we need. We get the difference between the journey and the destination. So let's head back to that field and finally figure out what in the world happened to our farmer. Okay, first things first. You know the drill in physics. We gotta get our units straight. The problem says the farmer walks for 2 minutes and 20 seconds. Let's just convert that all into seconds to make life easier. So 2 minutes is 120 seconds, plus that extra 20, and we get a total walking time of 140 seconds. Simple enough.
Now, let's trace his steps. The field is a perfect 10-meter square. So one full lap around the edge is 40 meters, and it takes him 40 seconds. So, in his 140 seconds of walking, how many laps is that? Well, 140 divided by 40, that's exactly 3.5 laps.
So, where does that actually put him on the field? Let's say he starts at corner A. The first 3 full laps are kind of irrelevant for his final position, right? Because each time, he just ends up right back at corner A. It's that final half lap that changes everything. Half a lap around the square takes him to the corner that's diagonally opposite from where he started. We'll call it corner C. So let's put it all together. His total distance traveled is that 140 meters we started with. No surprise there. But his displacement, that's the direct straight line path from his start point A to his end point C. And if you look at the field, that line perfectly cuts the square in half, creating a right-angled triangle.
And how do we find the length of that diagonal line, the hypotenuse? Well, we get to pull out an old friend from math class, the Pythagorean theorem. A squared plus b squared equals c squared. In our case, the two sides are both 10 meters long. So we just need to find the square root of 10 squared plus 10 squared.
And when you punch those numbers into a calculator, the square root of 200, what do you get? Bingo! 14.14 meters. And there you have it. The farmer walked a distance of 140 meters, but his final displacement from his starting point is only about 14 meters. Puzzle solved.
You know, this whole idea that your distance can be huge while your displacement is tiny, it actually leads to a really cool kind of mind-bending extreme case.
So let me ask you this. Is it even possible to cover a huge amount of ground, but have your final displacement be absolute zero?
Oh, absolutely. And it's something many of us have actually done. Just imagine running one full lap around a 400-meter track. Your watch will proudly tell you you've covered a distance of 400 meters. But where did you end up? Right back on the starting line. So the straight line distance between your start point and your end point is zero. Nada. Zilch.
All right, so let's tie all of this together with a nice bow. What are the big ideas that you should really walk away with from all this? Let's do a quick recap.
So what are the key things to remember? Number 1, scalar versus vector. One's just a number, the other has a number and a direction. Easy. Number 2, distance versus displacement. Distance is the whole journey, every step. Displacement is just the direct shortcut from start to finish. And finally, number 3, your displacement can be zero even if you've traveled for miles and miles as long as you end up back where you started.
So I'm going to leave you with a little challenge. The next time you're out and about, maybe driving to work or just walking from the couch to the fridge and back, ask yourself, what was my distance and what was my displacement? I'll give you